So good morning all. Today I shall be delivering on basically convolutional neural network, which is nothing but a deep neural network. There are various other deep neural network also, but this CNN is very popular when we consider this computer vision kind of task. So these are the content of the presentation, like why there is a necessity of sigmoidal neuron, then some basics of deep learning, followed by the depth knowledge of CNN. Like if we see the notion of deep learning, so just consider a task like whether we are interested in recognizing whether the input image is a face image or not. So basically, this is the problem. Like, is this a face? Okay. So what could be the various characteristics to find out whether the input image is a face image or not? So there are various characteristics or features, like there should be a top eye, eye in the top left, eye in the top right, then nose in the middle, mouth at the bottom. Based on all these characteristics, we can conclude, okay, this is a face image or this is not a face image. So what input we are providing? We are providing this input in terms of vector or in terms of 2D matrix, in terms of 3D matrix, like this. Now, if we consider this entire scenario in terms of a neural network, so we can consider this as a three-layer neural network. That first one is input layer, second one is this hidden layer, and then last one is this final layer. Now, just look at this recursive decomposition. Like previously, this is the problem. Is this a face? And these are the subproblems. Is there an eye in top left? So this subproblem can be further decomposed into several other subproblems. Like how can we recognize whether the input image is an eye image or not? So that particular subproblem is once again broken up into several subproblems. So this subproblem is once again divided into three parts. So there are features that can recognize whether this is an eye. So there should be eyebrow, there should be eyelashes, and there should be an iris. So based on this, we can consider that okay, this is an eye. So ultimately, what is happening? This subproblem is divided into several subproblems. The second subproblem is once again divided into several other subproblems. Likewise, if we look at in the context of neural network, so what is happening over here? We are inserting one more layer between that input and the hidden layer. So this three-layer neural network is getting transformed into four-layer neural network. Likewise, we are inserting the layers. So it is not a 3 or 4 layers in a deep neural network. We are inserting around 100 to 200 layers are there in a neural network. And if these many layers are there, then the billions of parameters would be associated with that neural network. This is the basic intuition behind this neural network. Coming back to deep learning once again, this ML is nothing but a subset of AI, and deep learning is a subset of ML. Once we go from AI to ML and ML to DL, then the size of the data set is getting increased. When we come to DL, then data set size should be very large. Then only we can get the advantage of deep learning. Otherwise, we can go with some traditional ML algorithms like SVM or random forest, like this. Basically, deep learning is getting popularity due to these three reasons. First of all, huge amount of data that is generated day by day. Then previously we are not having enough computational capability to process that large amount of data, but nowadays we are having powerful workstation, larger GPU. Then success story of deep learning in various domains. So it is not only doing good in computer vision, but also in NLP, in other forecasting tasks. So this can be considered as the main pillar of the success of deep learning. If we consider that statistical side, so see the size of the data. Size of data, if we consider that MS Coco data set, so that is 19 GB. Then ImageNet, in which it is once again a classification kind of data. Here 180 GB is the size of the data, and ImageNet, the larger version of ImageNet is nothing but 22,000, where a few terabytes size of the data. Then see 100 to 200 layers are there in a neural network. And faster prototyping means if we train that neural network, then how long it will take to train that particular model. So sometimes it may take several days to a month also if we consider the training on various large workstation, including GPU also. So this was the difference between small neural network and deep neural network, and it is a plot between data size versus model performance. Deep model is performing only when good only when the size of the data is very large. Otherwise, this traditional ML algorithm is outperforming to that deep neural networks. So preferably we will be using this CNN. It is nothing but a deep neural network, which is basically considered as an automatic feature extractor. So previously we need to do some manual feature engineering when we consider ML algorithm, but nowadays with the help of CNN, automatic feature engineering is taking place, and we do not need to do manual feature engineering. So basically what is happening in CNN, yeah, these are the various application domains in computer vision side, in NLP side. So this is the basic intuition. From this intuition, we can understand that how CNN is working. So basically, one input image is provided to us, that and on that we need to recognize which kind of object is present in that particular image. So one filter is there. That filter is known as convolutional filter, which is revolving over the input, and it is just extracting that feature map. So this is the first convolutional layer. Then after that, we are having this pooling layer, which is responsible for extracting the dominating features. So convolutional followed by pooling is nothing but the first convolutional layer. So there are neurons in convolutional layer. So we use activation function. So there are various kind of activation function like NH, sigmoid, ReLU. So preferably ReLU is used as an activation function for convolutional layer. This is first convolutional layer followed by second convolutional layer. So convolutional layers act as a feature extractor. After these convolutional layers, we are having several fully connected layers. First of all, that volume is converted into vector, which is done using this flatten layer. After that, some more fully connected layers there, fully connected layers are there. And lastly, that softmax, which compute the probability, like what is the probability that input image is a car, what is the probability that input image is a truck, like this, such that summation of all this probability is equal to 1. So we just take the maximum probability and we will conclude that okay, this is the car image. We can see the hands-on on this also. So I am having one program, so we can see side by side the execution of that program. Like how can we build that CNN? Okay, so before looking at this program, we will see the various layers of this CNN. So it is once again the same program, similar kind of problem actually. Here we need to recognize the handwritten digits, whether the handwritten digits is of 2, 3 like this. So there are total 10 categories are there. Here also we are providing several convolutional layer, then followed by pooling layer. After that one more convolutional layer, then followed by pooling layer. So here the depth of this input is nothing but showing the number of filters that we are applying. Basically, we need to apply number of filters. So while number of filters are applied, we consider an example in which suppose one filter is applied for detection of horizontal edge. So that filter is recognizing the horizontal edge across all the input. Then second filter is applied for detection of vertical edge like this. Another filter may be applied for detection of circle. So this could be the various reason behind applying multiple filters. Then this is nothing but the generic architecture of a CNN. Input is there. After that, convolutional layer is there. The neuron of the convolutional layer is activated using ReLU. Then it is repeated I times, followed by pulling. This pulling layer is there, which is optional. We may use pulling, we may not use pulling. Then convolutional followed by pulling. This entire architecture is repeated J times. Then after that, some more fully connected layers are there. The neuron is activated once again using ReLU. Then this architecture is repeated K times. After that, some more fully connected layers are there, which is repeated L times. This I, J, K, and L, these are nothing but the integers. If we look at this example, in which we are using convolutional followed by pulling. So here we can consider that the value of J is equal to 2. Convolutional followed by pulling, it is repeated 2 times. That's why the value of J is equal to 2 here. These are the various architectural layers: convolutional layer, pulling layer, fully connected layer, or dense layer. So basically, it's a mathematical operation. We apply filter on the input, we perform element-wise multiplication, and then finally that all these values are added, and we generate final output value. So using this animation, we can consider that this input is provided to us. The size of that input is 5 cross 5, and the filter is revolving over that input. The filter size is 3 cross 3. Filter size is nothing but the weight matrix that we are providing. We are performing element-wise multiplication, and then finally this output feature map is generated. This 4, 3, 4 like this. Spatial arrangement. What could be the dimension of the output volume? So it depends on 4 things. The very first one is that the spatial extent. What is the filter size? Whether it is 3 cross 3, whether it is 5 cross 5, 4 cross 4. This is the first thing. Second thing, depth. How many filters we are applying? In the previous animation, we are applying single filter. Okay. So we may apply multiple filters also. The third thing is stride, by which the filter is shifted over the input. If it is shifted by one position, then the stride is 1. If it is shifted by 2 position, then the stride is 2. In this animation, stride is 1. It is shifted by one position. But it is also possible you can decide the stride and it is shifted by 2 position. It completely depends on the application. Then last thing is zero padding. Whether any zero padding is applied on the boundary of the input. This is the last thing. This is another animation. This is the first filter that is applied. We generate first feature map. Then green filter is applied. We generate second feature map. So in this animation, we are applying 2 feature map. The output means the feature maps are cascaded in the depth-wise fashion. Like here, we are applying 2 filters. That's why the depth of the output is 2. If we would have applied 20 filters, then the depth of the output would be 20 only. This is the example in which we can understand the parameters. In any deep neural network, the number of parameters plays a very crucial role because the number of parameters defines the model complexity. So here we can consider that input. It's a colored input that we are providing. The 3 channels are there in that input. The size of that input is 6 cross 6. So the total volume of input that we are providing is 6 cross 6 cross 3. And here we are providing 2 filters, that is filter 1 and filter 2. Once again, the number of channel in the filter is equal to number of channel in the input. Like input में अगर 3 channel है, तो filter में भी 3 channels होंगे. So total how many parameters are associated with filter 1 that we need to identify. So this first layer, it's a 3 cross 3 means 9 weights. Second 3 cross 3 means once again 9 weights. Then third 3 cross 3 means once again 9 weights. So 9 plus 9 plus 9. So total 27 weights are associated. So how this multiplication is taking place? That 4 is multiplied by 1, 9 is multiplied by 0, 2 is multiplied by -1. This is happening at first layer. On that second layer of filter is multiplied by second layer of input. third layer of filter is multiplied by third layer of input, and finally all these value, total how many values? 27 values are added, and then we generate the very first entry, this one. This entry is generated over here. This one. So 27 weights are there. On this 27 weight, we are having one bias. So total number of parameters associated with filter 1 is 28. 27 weights plus one bias. So this is nothing but this is nothing but the output of applying filter 1 on this input, and this is nothing but the output of applying filter 2 on the same input. These outputs are cascaded in a depth-wise fashion. So the shape of output is 4 cross 4, and why depth is 2? Because we are applying two filters. So the total number of parameters associated with this operation is nothing but 28 multiplied by 2. 28 parameters are associated with first filter. Similarly, 28 parameters would be associated with second filter. 28 plus 28 like this. Then pooling layer is responsible for extracting the dominating features. There are various kinds of pooling to max pooling, average pooling. So here no parameters are associated. We just consider that region, and from that region we extract the maximum value. This is the logic behind pooling. So there are two types of pooling: max pooling, average pooling. Generally we use max pooling. So we consider this example in which we are providing input of size 4 cross 4. So that we are applying 2 cross 2 max pool. So 2 cross 2 region is considered. The maximum value is 20. 20 is taken out. Remaining all the values are ignored. Then second consideration is this 30 0 2 0. That is the region of consideration. From that we extract that maximum value 30, and remaining all are ignored. Like this. Then dense layer are there. This is nothing but a fully connected layer. So the meaning of fully connected layer is that neuron in a layer is connected to all the neurons of the previous layer. This is nothing but dense or fully connected layer. This is the animation. So here one input is there. It is nothing but in unrolled fashion. So only one input, and how many filters we are applying? We are applying once again same one filter, but it is in unrolled fashion. Okay, this is the first channel, second channel, third channel. Only one filter is applied over here. There are 3 channels in one filter. So total 9 weights from this first channel, 9 weights from this second channel, 9 weights from this third channel, and then plus 1. This is nothing but that bias that we are talking about, and this is the entry that we are generating. Okay. With this exercise, we can see how the number of parameters are considered. Suppose that input is provided to us, the size of that input is 32, 32, 3, means width is 32, height is 32, and the number of channel is 3. So if we consider that total how many values are there, so that can be decided with the help of that activation size. 32 multiplied by 32 multiplied by 3 is nothing but that 3072. And here we are not associated any parameter because अभी तक हमने कुछ नहीं किया है, ठीक है. Then second, we are applying the very first filter, that is nothing but this convolutional one. This filter is applied. Size of this filter is 5 cross 5 and stride is 1. Size of this filter is 5 cross 5 and the stride is 1. Look at this. On this 30 to 32, we are applying a filter of size 5 cross 5. So the output shape is 28, 28. See, what would be the logic? Here, this is the input of size 5 cross 5. Here we are applying a filter of size 3 cross 3. What is the output shape? 3 cross 3. So output shape can be determined as input shape minus filter shape plus 1. 5 minus 3 plus 1. So that is nothing but the output. So similarly here, in this exercise, 30 to 32 is get converted into 28, 28. Formula is 32 minus 5 plus 1. 32 minus 5 plus 1. So total how many values are there? If we look at this 28, 28, 8. So it is nothing but 28 multiplied by 28 multiplied by 8. So these many values are there, 6272. The next question is that from where this 8 is coming into picture. 28, 28 is clear, but what about this 8? That 8 is nothing but the number of filters that we are applying. That 8 is nothing but the number of filters. You have decided this. So this 8 is nothing but the number of filters. The next question is that how we can compute the number of parameters. So I can explain this. 5 cross 5 filter is applied. This 5 cross 5 filter is applied. How many channels would be there in the filter? The number of channel in the filter is equal to number of channel in the input. So कौन से इनपुट पे अप्लाई किया है उसको 32 3 पर अप्लाई किया है 3 चैनल्स है उसमें ठीक है तो 5 क्रॉस 5 का फिल्टर है फर्स्ट 5 क्रॉस 5 मींस 25 वेट्स सेकंड 5 क्रॉस 5 another 25 वेट्स थर्ड 5 क्रॉस 5 मींस another 25 वेट्स 25 plus 25 plus 25 75 weights are there. On top of that one bias would be there, that is nothing but 76. 76 parameters are associated with single filter, and how many such filters we are applying? 8. So 76 multiplied by 8 is nothing but that 608. I will explain once again this when we look at this convolutional 2. Then 28, 28, 28, 28, 8. We are applying 2 cross 2 max pool on that. If we are applying 2 cross 2 max pool on 28, 28, so 28, 28 is get converted into 14, 14. The number of channel would be unchanged. In that pooling operation, number of channels is not getting changed. So 28, 28, 8 is converted to 14, 14, 8. Then to 14, 14, 8 means how many values? 14 multiplied by 14 multiplied by 8 is nothing but 1568. In pooling operation, no parameters are associated. So look at this number of parameters in that third row is equal to 0. Now we are applying second convolutional layer. In that second convolutional layer, once again that 5 cross 5 filter is applied. But on which input we are applying? This convolutional 2 is applied on this input 14, 14, 8. On 14, 14, 8 we are applying second convolutional. And what is the size of that filter? Once again 5 cross 5. So how many channels would be there in the filter? Total 8 channels would be there. Why? Because on which input we are applying? We are applying on this input 14, 14, 8. In that 14, 14, 8, 8 channels are there. That's why the filter that we are applying, in that filter also 8 channels would be there. So 5 cross 5 filter, total 8 channels. So total how many weights would be there? 25 multiplied by 8. 25 weights for first channel, 25 weights for second channel. Total how many channels are there? 8. So 25 multiplied by 8 is nothing but 200. On top of that we are having single bias. So 200 plus 1 will become 201. And how many such filters we are applying now? 16 filters. So 201 is multiplied by 16 is nothing but that last entry 3216. Then we are having pooling layer. That 10, 10 is converted into 5, 5. Then after that fully connected layer is there 120. So what this 120 is indicating in that fully connected layer? Each of these 120 neurons is connected to all the neurons of the previous layer. And how many such neurons are there in the previous layer? This 400 is nothing but the previous layer neuron. So in the first layer 400 neurons, in that second 120 neurons are there. These 120 neurons are connected to these 400 neurons in a fully connected fashion. So total how many weights would be there? 120 multiplied by 400. 120 multiplied by 400 is nothing but 48,000. And in that output, how many neurons are there? 120. Each of these neuron is having single bias. So 48,000 weights plus 120 bias. 48,000 weights plus 120 bias. 48,120 is nothing but the total number of parameters would be associated. That is the last entry in that third last row. After that, one more fully connected layer is there. In that fully connected layer, 84 neurons are there. That 84 neuron is connected to 120 neurons of the previous layer. So 84 multiplied by 120 plus 84 is nothing but that 10164. After that, this 10 neurons are there. These 10 neurons are connected to these 84 neurons in a fully connected fashion. So formula is 10 multiplied by 84, these many weights, plus 10 bias. So 840 plus 10 is nothing but that 850. So these are nothing but the total number of parameters. 608 plus 8216 plus this plus this plus this. With the help of gradient descent or backpropagation algorithm, we need to identify the optimal value of each of these parameters. This is the summary of convolutional neural network. We provide an input image, then we decide the number of filters, number of channels that we are applying, then how many filters are there, how many neurons are there in that layer, total how many convolutional layers are there, after that how many fully connected layers are there, and lastly the softmax layer for that classification task. So all these things that we are looking in the context of computer vision kind of problems. It is nothing but an example of classic neural network. So there are various pre-trained neural networks are there based on CNN like LeNet5, AlexNet, GoogleNet, VGG, InceptionNet. So if you look at this, once again the same architecture is there. Pre-trained CNN means this model is already trained on some predefined data set. That is nothing but pre-trained CNN. Means the weight and the bias, the parameters of this neural network have already been trained and we know the optimal value of these parameters. This is the meaning of pre-trained network. Grayscale input is the input, like black and white images are given. That's why the number of channel is in the input is equal to 1. So the 32 is the width and 32 is the height. This 32 input is there. On this 32 we are applying a filter of size 5 cross 5. So 32 is converted into 28. And how many channels are there in the output? 6 channels are there. Here 6 channels are there. 1, 2, 3, 4, 5, 6. Why 6 channels? Because we are applying 6 filters. If we would have applied 60 filters, then the depth would be 60. After this first convolutional layer, we are having max pooling 28 is converted into 14. Then another convolutional layer 14 is converted to 10. Why? 14 minus 5 plus 1. It is nothing but 10. And after that, how many convolutional layer we are convolutional filter that we are applying? 16. So the shape is 10 multiplied by 10 multiplied by 16. 10 is converted into 5 max pool. Then fully connected layers are there. This is nothing but our AlexNet model. In this model, 60 million parameters are associated. 60 million parameters are there in this. 5 convolutional layer and 3 max pooling layers are there. If you look at the detail of this is the nothing but the detailed architecture of this. This input is a colored input which we are having 3 channels. The shape of the input is 3. On this 3, we are applying a filter. The size of that filter is 11 cross 11. 11 cross 11 is filter is applied. Stride is equal to 4. 96 filters are applied. Just see if 96 filters are applied, see the depth is nothing but 96. After that, max pooling is there, then second convolutional, then max pool, third convolutional like this. Some more fully connected layers are there. In this fully connected layer, around 4,000 neurons are there in this fully connected layer, and this 4,000 neurons are there. Then this 1,000 neurons are there in the last layer. Means it's a classification problem, and total how many categories are there? 1,000 categories are there. The total number of parameters are nothing but 60 million parameters. We will see one program like how we can build a CNN. Sir, this screen is not visible. Screen visible. PPT visible. Sir, PPT share किया. Print. पूरी screen share. Browser. ठीक है. ठीक है, हो जाएगा. one example where we can build this CNN. Basically, one data set is there. The data set is MNIST data set. It's nothing but a data set of handwritten and digits. So total 70,000 class images are there in that data set. 60,000 images are for training and 10,000 is used for testing data set. Total 10 categories are there, class 0 to class 9. So for this we need to build this CNN. So we are using this Keras library. So basically, first of all, we need to import all these things. After importing, we need to define total how many classes are there. So number of classes is equal to 10. Input shape is 28, 28. All these images are grayscale image. That's why the input shape is 28, 28, 1. Then then we need to load this data set. So we need to define these four parameters: X train, Y train, X validation, and Y validation, or X test or Y test. So basically, training data and testing data. From this Keras data set, we need to load this keras.dataset.mnis.load data. So there we need to define these four variables. So X is nothing but our input image, and Y is the label. It's a label data set. So X train means training set images. Y train means training set labels. Then X test means testing set images, and Y test means labels of testing. Then some sort of normalization that we need to do. Now input shape is this 28, 28 on in this particular matrix. All the values are there. The minimum value is 0 and the maximum value is 255. We do not want to operate upon this large value. That's why we use this normalization step. We divide each and every value in that matrix by 255. So the previous range was 0 to 255. When we divide each and every entry by 255, then the new range would be 0 to 1. Then the value is between 0 to 1, and we need to work upon the smaller value as compared to the previous one. So we can run this. So see the shape of this training shape. X train shape is 60,000 images are there, and the shape of each and every image is 28, 28, 1. So the total shape is 60,000, 28, 28, 1. This is the total shape. Similarly, X shape is this 10,000, 10,000 testing images are there. So the shape is 10,000, 28, 28, 1. So 60,000 training images and 10,000 testing images are there. After that, we need to build the model. So this is nothing but we can build the model. So the model is sequential. The meaning is that one layer is there, after that second layer, after that third layer is there. This kind of model is known as sequential model. So we take input, keras.input is equal to that input shape. After that we are providing this input. It is nothing but the syntax of this keras, layer.conv2d. Here we need, the first parameter is nothing but the number of filters that we need to apply. Here we are applying 32 filters. Then filter size is 3 cross 3 and execution is ALU. Then max pool 2D and max pooling is 2 cross 2. After that second convolutional layer, in that second convolutional layer we are providing 64 filters. Then kernel size, filter size is 3 cross 3. Once again activation is ReLU. Then we are using this max pool 2D. We can see the syntax of this in this help of keras. See, this is the syntax. The very first parameter is nothing but that filter. अगर आप वहाँ पर 100 mention करोगे, it indicates that 100 filters are there. The very first parameter, that is nothing but the compulsory parameters that we need to provide is the filter. Second is kernel size. third one is stride, fourth one is padding. You may apply this or you may not supply all these parameters, but number of filters that we need to define. So we just run this cell. So the total number of parameters are this. C. Now the next one is running the model. So we need to define the batch size. What do we mean by that? Batch size of 128. So total 60,000 samples are there. So if we define batch size is equal to 128, so what it indicates? We select 128 sample, we apply backpropagation. There are 4 steps in the backpropagation or gradient descent algorithm. First one is forward pass, second one is computing the loss, third one is backward pass. In backward pass, we compute the gradient. So what do we mean by that? Gradient is nothing but a vector of partial derivative of that cost function with respect to all the parameters. That is nothing but weight and biases. And the last step is nothing but the update parameters. The formula for this is parameter is equal to parameter minus learning rate multiplied by the gradient that we obtained in the step 3. So first batch is considered, then you perform this gradient descent. Then second set of 128 sample, then you perform gradient descent. Third set of 128 sample, then once again you perform gradient descent, like this. Epoch is nothing but consideration of all the 60,000 sample. All this 60,000 sample, how many times this 60,000 samples are considered? It is nothing but number of epochs. So 4 times this is considered, that's why epoch is equal to 4. Then model.compile, here we need to define 3 things. Which loss function we are using, what will be the evaluation matrix for evaluation the model, then which optimizer that we are using. So here we are using this loss function. The name of this loss function is categorical cross entropy loss. Optimizer that we are using is nothing but Adams optimizer. Adams optimizer is nothing but a combination of momentum and RMS prop. Both momentum and RMS prop use internally this exponentially moving weighted average. Then accuracy is the matrix on which we are evaluating the model. There are other performance metrics also like precision, recall, F1 score. वो आप define कर सकते हो. Then model.fit is nothing but the actual training of the model. In model.fit, we need to supply all the data, training data, validation data. Then you need to evaluate the model. See this epoch, which epoch is running now? The first epoch. And what this progress bar is indicating? It is taking that sample of 128, 128 and that backpropagation is running. You can see loss is getting decreased, accuracy is getting increased. But which loss and which accuracy we are talking about? Which loss and which accuracy here we are talking about? This is nothing but loss and accuracy of training data. This is nothing but the loss and accuracy of training data. At last, one more loss and accuracy is printed. Just look at this. This loss is nothing but this loss and accuracy is the training loss and training accuracy. Here, one more loss and validation accuracy is there. After the completion of one epoch, what do we mean by that? After the completion of one epoch, after the consideration of 60,000 sample, we just test how the model is performing on the validation data. Validation data means that holdout sample of 10,000 data. So on that we evaluate it. So you can see the validation loss is this and validation accuracy is this. After this, second epoch is started. Second epoch is running. Then third epoch is started. Third epoch is running. Here we can see why this progress bar is indicated. This is nothing but our progress bar. Here one more thing is there. This verbose is equal to 1. We define verbose is equal to 1. That's why that progress bar is indicated. We can also define progress bar verbose is equal to 0. We can also define progress bar is verbose is equal to 2. Like if we define verbose is equal to 2, then that indication or that progress is not shown. Directly you will get the output. This is the meaning. Okay, so this is the last epoch. In that last epoch, just look at this. What is the accuracy in last epoch? Around 97 or 98% accuracy that we are getting. How accuracy is defined? Accuracy is nothing but the total correct prediction divided by the total number of samples. So this loss and this accuracy pertaining to the training accuracy. At last, we will be evaluating the model on the validation data. So we will see how the model is performing on training and how the model is performing on validation. Uh, Training accuracy is 97% and validation accuracy is 98%. But generally what happens? The training accuracy is high and validation accuracy is low. Okay, if the difference between training and validation accuracy is very high, it indicates that the overfitting problem in the model. So there are various methods for resolving that overfitting problem. One of the very important method is known as that regularization. There are various kinds of regularization, but we will not go into in the detail of this. I just wanted to explain regularization here because I think once we define this model, then we also use dropout here. Just look at this here. We have used this dropout. Dropout is nothing but a kind of regularization. Here we are using 50% dropout. 50% dropout means 50% of the neuron of that model is randomly shut down. That is nothing but 50% dropout that we are using. Now at last we will be looking at after training how the model is performing on the final evaluation data. So model.evaluate. So corresponding to model, three things are there. First one, model.compile. Second, model.fit. Third, model.evaluate. Model.compile, उसमें आप तीन चीजें डिसाइड करते हो कि कौन सा लॉस आप यूज करने वाले हो, कौन सा परफॉर्मेंस मैट्रिक्स यूज करोगे और which optimizer that we will be using. Then model.fit is nothing but actual training of the model, and model.evaluate means how the model is performing on the data which it has not seen before, means the generalizational ability of the model on the unseen data is nothing but model.evaluate. How model is performing? Test accuracy is 98%. This is the test accuracy. Okay, so I think this was all about from my side based on CNN. If any doubt or query is there, then we can ask.
So for input,
Yes.
why we use the padding? We use the padding around this.
Yes, why we use actually padding? There are two things. Like suppose if we want that input shape should be same as output shape. For some of the application, we want that input shape is suppose 2828 and output shape should also be 2828. Then what we do? We apply padding of zeros on the boundary of input, and we apply a filter. That's there is one reason, and another reason is that sometimes that filter do not properly fit on the input. Like if you look at that input size is 5 cross 5. So if we take a filter of size 4 cross 4 or filter of size 3 cross 3. Just a minute. Okay, look at this. Okay. See, this in this example, the input shape is 5 cross 5 and the filter shape is 3 cross 3. What is the stride over here? Stride is 1 because it is shifted by one position. So suppose if stride is equal to 2, if stride would be 2, then this would be the first region of consideration. Then it is shifted by 2 positions and it comes here. One more possibility is there. If stride is equal to 3, then what would happen? If stride would be 3, then the filter would be shifted by 3 positions, but the last column of that input would not be there. In that scenario, when the proper input boundaries are not available, in that scenario we need to provide that padding of zeros. lots of research is going on in this deep models in terms of transformers. Like previously, CNN was the only model that was very dominating model in the context of computer vision. But nowadays, transformer models, specifically that vision transformer, that stable diffusion, these are the latest model which is performing a good impact on this computer vision side. Basically, if we look at this, the series of YOLO, uh, which is performing good for this object detection kind of task. YOLO V8 is launched, I think, recently.
YOLO is the latest one.
Yes, YOLO is the latest model actually.
So there
Basically,
are
two types of object detectors are there: single shot and two shot detectors. So, preferably, YOLO is used over here.
image classification के लिए we cannot use the YOLO.
No, for image classification, we can use this YOLO, but we need to modify the model input and model output. Means some more layers should be added. So YOLO will perform feature extraction task for you, and later on you are having some more layers for classification purpose. It may depend on the application, like how many classes are there in your application.
So there one small project we have a student uniform brain tumor.
Yes.
So I wanted to get my thinking from human.
Yes, you can also apply the CNN. Not CNN from scratch. You should use this pre-trained CNN. Use pre-trained CNN, and you can have a transfer learning after that. Transfer learning. So probably you will get good result after transfer learning. And another thing that you can also explore the data augmentation in that data set. If you perform the augmentation in the data set, and good augmentation will generate good generalization.
So for image classifications, we can use the Inception's series also.
Yes, Inception is also a pre-trained CNN.
Which are
There are various variant of Inception, like Inception V1, V2, V3, V4.
before.
So it may possible like this variant is performing good for this application, and it is not performing good for other application also. So we need to completely look at the variant, like which there are various optimizations or heuristics that are applied for Inception. Like Inception V3 was there. On that we are applying some more heuristics. They are applying some optimizer. Then they produce this Inception V4. So probably it may or may not be helpful in specific application. ResNet is there.
VGG also is there.
Yeah, VGG is there.
So इसमें ये फ्यूजन का भी कंसेप्ट आता है, फ्यूजन ऑफ फीचर्स,
Fusion.
जो फीचर मैप्स है,
हाँ.
we can combine the feature maps of the layers, then again try to extract the features from combining the multiple features of the layers.
No. Fusion. I think you are talking about that multimodal data. So multimodal data, if we look at that fusion, so two kinds of fusions are there. One is that feature level fusion, and another one is decision level fusion. So in that feature level, like if we consider that YouTube video in which multiple modalities are there, that video frames are there, then audio is also there, and suppose some subscript is also running at last. So we need to process that textual modality, visual modality, and audio modality. So what we can do, we can extract the features from visual modality, audio modality, and all these extracted features are first clubbed and then pass it to classification. This is feature level fusion. On the other hand, what is decision level fusion? You just process that visual modality, you get the decision. You just process that audio modality, get the decision, and then you process the last modality and get the decision. On that, you take the majority or some sort of weighted ensemble you can prepare for that. That is the second kind of quiz.
We can use hybrid model also, sir.
Yes.
We can use hybrid model also.
Yes, preferably researchers nowadays are using this ensemble modeling.
Yes.
Actually, CNN is a very vast topic around. It takes 4 to 5 classes to cover the complete CNN. And in that also we do not cover the advanced part of CNN. Basically we
Thank you so much, sir, for sharing your valuable knowledge with
thank
us.
you.
And it's very fruitful session. Now I request Jagar ma'am to facilitate the sir with moment.